Happy day, guys. This is Pungave Kalamegam from Inspiring Imprints with the 6th problem on patterns. This is one of the kind like our Fibonacci series. Okay, it's look and say. All you'll have to do is look and say. Okay, so we'll move on. So this is the problem statement. So given a number n, you will have to print the nth term in the look and say series. So the look and say series goes like this: 1, 11, 21, 1211, and goes on and on. Okay, so n must be a positive integer, and for that positive integer you will get the nth term in the look and say sequence. First term is always 1. Okay, like our Fibonacci series, here also we have a first term which is 1, and the second term, as the look and say says, look at the first term and say what is there. So it has 1, right? So 1 is there in the previous term. In the third term, we'll have to look at the second term. We'll have to look at the second term and say 2 1s are there in the second term. Okay. In the fourth, you'll have to look at the third term and say 1 2 is there and 1 1 is there, right? So if you could gather what's happening, it's actually counting the number of digits, each number of digits, and putting that as a prefix and the number as such. Then the number of digits and the number till the 7th term. We are going to see how it goes. So the count until, so where does the, till when you'll have to count? You'll have to count till you have the same digit. Okay. If the digits are changing, okay, so if you check on this 5th term, so you'll have to count all the ones, so 3 1s, and you'll have to count all the 2s, 2 2s. You'll have to count 1. If there are some other digits ones here, you'll have to count that also. So you'll have to count, put the count here and the number next to it, and keep moving ahead. I'm going to give you 2 different solutions. One which goes with adding up an extra character at the end of the term, and then it calculates the next term. So also it goes with the assumption of first and second term is hard coded, which means the first and second term is already fixed as 1 and 1 1, and then it calculates for the from the third term. Okay, so it starts from the first digit, and let that first digit be f, and it starts counting the number of f's in the sequence. When you get the count, you just append it, okay, and move on to the next digit. This is the first one. Okay, so this is the Python program for the algorithm. In the algorithm, I have not given any dictionary, right? I've not given dictionary. Here I've used dictionary to keep counting number 1, and also to find out if there is a change in the digit. Okay, so that's, I keep clearing the elements for every digit that I'm going to count. Okay, I've just used a dictionary so that I can find out if that particular element is already in the dictionary or not. Okay, you can come up with some other logic also. This is the first approach of look and say, wherein we would be using a dictionary to add the count the number of numbers, and then we would be saying it aloud by adding it to the resultant string. Okay, that is how we would be doing. And one another thing is we will be adding hard coding the first two terms of look and say. Okay, so we'll quickly run through this for an input 7. So let's see how it works. So next. So we are first generating each of the terms, and for each of the term there is a dictionary that is getting created, and for counting the digits. Okay, so 2 1 second third term has been generated, 21. Now with the third term we are going to generate the fourth term, so you are counting and getting the third. So like this we will keep moving on. So if you see the last term, you could see 1 3 1 1 2 2 and 1 is the last term. Next approach is I'm going to use several while loops to find out the nth term. So here what is happening is we start with the first term, and for every new term that is getting generated, I'll have to repeat counting every digit. Okay, till when I do this is either till I get a different digit or till the last term. So here I have a solution to go till the last term, so I do not have to add one extra symbol in the end. Okay, however in the first approach we had to have an extra term. So this is the program. It is far smaller than the first approach. However, it has too many whiles. In the second approach, we have 3 while loops, and each of the while loop will go for, one would be going for the number of terms, the other would be generating the terms, and the last one is to count the terms. Okay, so these are the 3 while loops, and for this particular concept, only the first term is hard coded. So term 1 starts with 1 and it moves ahead. So let's give the same input as 7 and check the program. So what it does is from the first term it generates the other set of terms. So this while in line number 4 is for each term. Okay, and it goes ahead and creates the other terms. Okay, so I'll just show how it's doing. So since I'm marking line 5 as the step, so that we can see only generation of each term. Okay, so I'll click on the next, so you can see the first term 1 is picked up as the input, and the next term will be generated. So if I give last, on the next, you can see the new term 1 1, and when I'm clicking again the next, I can get the new term. You will not be iterating into every while inside this while, because I have highlighted this as the step. Okay, this is one another benefit of Python tutor. So to avoid all the function flow, you can just check on one particular while. So you can see the new terms getting generated. Okay, so 7th term is generated. So you just get to print it and finish off. Thanks for watching till the end, guys. I am finishing off patterns as of today, and we are starting with a fresh batch of problems for strings. I have chosen 10 problems. Keep looking out for those problems and get benefited. Bye. See you.